Okay, guys, here's the control matrix question. It's actually one of the easiest Rechenaufgabe out there. So the question will always give you a control matrix B, and it's going to be a regular matrix. And first, they're going to ask you to give a basis of the matrix C. And the matrix C is always the null space of B. So to find that, it's really easy. Just do Gauss, which is what I've done here. That's the matrix B. And you do some very simple Gauss, and then you'll end up with something like that. Actually, Gauss was done within one step, but if you want, you can clean it up like I did a little bit more, get rid of the ones over here. And yeah. So once you've done that, then just read out the null space as usual. You have your pivots over here. You've got your free columns over here. And the idea is to let the free variables equal themselves and write the pivot variables in terms of the free variables. Once you've done that, obviously that's going to be your null space, right? So the null space is obviously going to be the linear combination of the columns. So it's going to be length 6, which is the width of your original matrix B. And you substitute the values that you found here into this, and out comes this little thing. Now I want to point out something that's very important, and it's the fact that all these matrices, B, C, whatever, they're all defined over F2. F2 means the set of 0 and 1 only. So we don't have a -1 in F2. And that's what I wrote here. C is in F2, so there is no -1. So all -1s become 1 in F2. Now, if you had, let's say at -2, that would be 0, -3, it would be 1, and so on. Or if you had +2, that would be 0 as well. So just make sure you do not forget to convert this base into the F2 field, all right? So these vectors that you have over here, right? In other words, the null space of B, that's going to be the basis of your matrix C, and that's the answer. Okay, so that's all you need to write. The next part is part B, and they're going to ask for the minimal distance of C. Well, first let's think about what C is. C is the set of all vectors that you can build from these three vectors, right? Because we said this is the basis of C. It's the set that you use to create all the vectors in C. And well, you just have to think, okay, so how many possible linear combinations of the bases are there? And that's going to be your vector, that's going to be your entire set C. So if you think about it, you can ignore this part for now. If you just draw your attention to this part, please. We see that, okay, if that's our bases, then there's only really 8 combinations because the scalars are only allowed to be 0, 1, right? So there's 2 options for this. You take 0 of it or you take 1 of it. There's 2 options for this. You take 0 of it or you take 1 of it, and the same goes for your third base. So 2 options and 2 options and 2 options, 2 power 3, that's 8 total options, and that's what I've done here. This one is when you take just 1 of the first base and none of the other ones. So that's just C1 alone. That's C2. In other words, you take 1 of C2 and none of the other 2. C3 is, the same as how you got C1, C2, but you take only C3. And then, of course, the other possible combinations are the remaining 5 out here, and that's easy to find. This one here is when you take 1 of this and 1 of that and none of this. So that's this. And that's when you take C1 and C3, and that's when you take C2 and C3, okay? And this one is when you take all of them. So if you take one of this, plus one of that, plus one of that, you're going to get this vector. And this one is when you take none of them, okay? So as I said, total 8 vectors because, you know, there's 8 total combinations. And now we're ready to answer the question, which is asking us for the minimal distance of C. This right here is your set C, all these vectors together. That was just the bases. And this is everything that you can make with bases, right? And again, I repeat, you're only allowed to take 0 of a vector or 1 of a vector because it's over F2, okay? You can't take 2 of this, you can't take 3 of this, because 2 and 3 are not in F2. F2 is only the set with 0 and 1. So the distance is the difference between one vector and another. So for example, the distance between C1 and C2, for example, between these two vectors right here, the distance is 4 because that's the number of bits that are different, right? The first bit is the same, so you don't count that. But the second, third, fourth, and fifth positions are different. So that means the distance between them is 4. And if you notice, between any two vectors from this group right here, the distance is always 4. The distance between any of these two vectors is also 4. And of course, the distance between this vector and this vector, for example, if we just take a look at this and that, what do you think? I think the difference is 6, right? Because every position is different. But maybe the distance between this one and this one, let's see, that's going to be 4 as a, no, that's 6 as well, yeah. Okay, so the idea is the minimal distance is you have to find the two most similar vectors and then figure out what is their distance. So here I found that these two have a difference of 2 because only the 2 middle entries are different. The rest are the same. So the distance here is 2, and that happens to be the minimal distance. Any other pair of vectors will not have a distance lower than 2. Of course, you could compare this vector over here with this vector over here, and you'll also see that the distance is 2. But in any case, the minimal distance of the entire set is 2. Okay? So the final answer is 2. Well, you don't have to write DC, just write 2 in there. Yeah. Next part is part C, and they're going to ask how many vectors that have weight 4. How many vectors of C have weight 4? Okay. And well, what's the weight of a vector? The weight is the number of ones in the vector. So for example, here the weight is 2 because there's 2 ones in the vector. Here the weight is 6 because there's 6 ones in the vector. That was easy. And well, if they're asking how many vectors have weight 4, that's easy to see. It's only these 3 guys, right? These 3 guys are the only ones that have 4 ones. The others have less than 4 ones or more than 4 ones. So the answer is 3. That was simple. The next part is going to ask for, oh, well, I suppose I forgot to write the answer. Voucher syndrome. Yeah, so that's the next question. They're going to ask Voucher syndrome haben Nebenklasse Anführer 1. So we've got 2 things that we want to know, that we want to define. The first is syndrome. Syndrome just means any of the possible column vectors over F2, well, of length 3. So in other words, if you take a look at B, right, each column is 3 positions long, right? It's a 3 by 1 vector. And syndrome just means of all the 3 by 1 vectors over 0 and 1, so over F2, yeah, sorry, let me rephrase that. The syndrome is any of the possible 8 vectors over 0, 1. Well, how many vectors over 0, 1 of length 3 are there? I mean, if you think about it from a combinatorics point of view, you've got 3 positions, right? Let me try to do that. You've got 3 positions, right? Here can be a 0 or 1, so you've got 2 options here. Here you've got 2 options, it can be a 0 or 1, and here you've got 2 more options, it can be 0 or 1. So all in all, you've got 8 possible options, right? And the 8 possible options are precisely these guys right here. See? That's all your 8 possible combinations, right? So those are all the possible syndromes you can have, okay? So that's a syndrome. That's it. They're always going to be the same. They're not just the ones that you find in B itself, but they're all the possible combinations you can take of a vector with 3 positions over 0, 1. The Nebenklassen is just another way of saying the linear combinations of the columns of B. So obviously, if you think about the matrix B here and you want to do Bx equals something, well, how many, what's X going to look like? I'm thinking X is going to look like, well, it's going to be a vector, right? And it's going to have the same, its rows, it's going to have 1 column, first of all, because it's a column vector. And it's got to have 1, 2, 3, 4, 5. Okay, in this case, it's going to be 5 positions long, right? Because otherwise it won't multiply. But in our case, we have different matrix B. Our matrix B is 6 positions long. So that just means our vector B is going to be 6 positions long. That's it. Because, well, this is how many of each column do you want, right? So let's go figure out what they want. So, okay, the question is asking which syndromes have which syndromes have a Nebenklassenanführ, so have a linear combination of 1. So that really is just the columns that you find in B. So if you look at this column, obviously it's one of the possible 8 vectors over F2, right? And what does it take to make this vector? Well, how about one of this column plus none of the other guys? None of the other columns. So what's a linear combination going to look like? The vector is now, the vector is now going to be, to get 1, 0, you're going to have 1 of the first column plus 0 of the other ones, right? And obviously that's just going to give you 1, 0, 0. Okay? The same. So that means this 1, 0, 0, the Nebenklassenanführ that produces it is the 1 and 4, 0. So you see that in the table here, right? To produce this guy, well, it's just going to take 1 of the first column and none of the other ones. To produce this syndrome, it's going to take, well, 1 of the second column, right? Because it's already there, and none of the other guys. So that was easy. And for 0, 0, 1, well, that's a middle column. So, one of the middle column and none of the other guys. To produce the 1, 1, 0, it's a little bit trickier because you don't actually have a 1, 1, 0 in your B, right? You're going to have to take some linear combinations of the columns. And, well, if you take one of the first and one of the second, you'll get a 1, 1, 0 as well. So the Nebenklassen-Anführer for these three vectors here have weight 1, right? Because it only takes one of them. The Nebenklassenanführer for this syndrome has weight 2 because you need 2 columns to make this syndrome. For this syndrome, well, 1, 0, 1, guess what? It's already a column of B, so you can just take one of it. And I think that's clear. So here's a table based on this example. This B is not our original B up here. It's a different example that I chose because it's nice and easy to explain with this example. Yeah, so the question is asking which syndromes have Nebenklassenanführer with weight 1, and well, that's going to be the syndromes that are already in B, right? So let's have a look at B, right? Here's our matrix B, and we have, well, so 1, 0, 1 is going to have Nebenklassenanführer with weight 1, 0, 1, 0, and 0, 1, 1. All the other columns are just the same as one of these, right? So the answer is really easy. It's 1, 0, 1, 0, 1, 1, 0, 1, 0. In other words, the syndromes that are already a column of B, okay? If it's Gewicht 1, it's very easy to answer. Just look at which column vector is in B, right? And those are the ones that have Nebenklassenanführer 1. If it's Gewicht 2, then, well, you got to think a little bit more, and you might want to draw out this table and figure out, okay, how do I make each of the syndromes? What are the possible combinations? For example, with this syndrome 110, there's 2 ways to make them. These 2 added together and none of the other ones, or the last 2, so this one, these 2 added together and none of the first ones, you'll get 110. But the good news is I am 99% sure they will only ask for Gewicht 1. All right, so that's it, guys. Good luck.